Hello everyone, Idloi here with another update. After roughly a month of using J, I think I'm in a convenient position to show where I'm currently at in building, rebuilding Fireopal. So far, I've been mostly focused on just building an engine sort of thing, not really, the game itself, but everything that's necessary to build the game in the end. So to start off just with a little tour, I made the engine thing based around plugins, and this is basically the main function, which just adds one plugin right now, and this is the actual game logic, or will be the game logic. For now, it's just test content. And the plugin itself is really simple. It just assigns a couple of callbacks and then has a bunch of data that it will use later on. This is something that they have, the plugins have access to basically in the callbacks. So they get a reference to themselves and they can do whatever is necessary in it. Shutdown events are separated from the update cycle, and then there is an update loop. There's also one additional callback for rendering, but that might not be something I'm going to keep. In any case, this is a really simple approach and it works well, so I'm not going to overcomplicate this in the future, probably, at least until I see a good reason to. And the other thing that I built out is entity storage. I'm going to show you the engine itself, so it's not terribly complicated. It has storage for entity managers, plugins, and events. And basically, the last time it was the frame time of the last frame. So something to use to calculate data times. This is probably not accurate or anything. The process I'm doing it on it, but it's fine for the moment. It's good enough. And the important part here is this typed storage thing, and the fact that I have multiple entity managers, because in my case I don't have something quote unquote called an entity. Well, I do, but it's not the main thing. Basically, this provides storage per each type I want to store. So everything has an ID that I want to store specifically in a separate array, and this just creates and gives access to the array, and allows me to add and look up things in a typed, statically typed manner. And it's not terribly complicated to use it. So I'm going to show just a few cases where I'm using it. So the very basic use case is where I'm iterating over all of the things. So in this case, I'm iterating over all of the. Maybe that's more visible for the video. So if I want to iterate over all of the nodes, which is something I'm using for the UI layout, I will show that in a minute. I can iterate over all of the entries of that array. Same for something else, in this case a canvas, specifically for the window. I can just iterate over all of them. And this is the basic usage. And if I want to have access to, let me just show you how a node looks like here. And basically it has a handle, which is its own handle, has a hierarchy, parent, children, and then there are things attached to it with other handles. I have two types of handles, a cached one and a non-cached one. The non-cached one is basically free. I just need to store the ID itself, and the type is compile time, so I don't need to pay per instance for storing additional information. The cached one has an additional ID basically to directly cache locations in the array of, in this case, the resolve layout array, which is just there for convenience and faster lookups if necessary. This is probably way overkill for my purposes. But basically I have this direct caching and the things that look up things. So let's say when I'm resolving the areas that are part of a layout, I want to look up the node that we are currently processing, and I can just say find that thing. And if it's a cached handle, I can try looking up with the cache with the cached ID. If it's not found by the ID, I can still look it up via a hash map storage, which should be still faster than just iterating over everything, I think, or at least there is a certain scale where it's faster. And then if it's not found, we can still just iterate over everything. So there are multiple layers of cache involved here already. Again, this is probably overkill for my purposes. But the neat part is the convenience. I can just say find that thing and the thing falls out or not. I just get the flag that tells me if it's been found or not. And this approach works for basically every type of entity, things that I'm storing as entities. So if I want to look up the resolve layout of the node, same thing. I just find it and then the right type just falls out, if it exists, of course. If it doesn't exist, I can just add it like so. And again, this is entirely type safe. So when I'm adding a resolve layout, I'm 100% sure it goes into the right array, and then I get a pointer to it, to the new entry. And it is the right type, of course. And this works for basically everything. So if I look at where I am finding things, finding the node, resolve layout, finding the clip, which is another type of entity that is basically optional for the node. So these ones are actually optional components because the node might not have defined clipping space. So it just inherits the parent's viewport. Same for the clip. If the node is not something that's pinned to something, this will not exist, or well, it will just, I'm just paying the price for the handle anyway. It will just not point to anything. Components that are not optional, of course, are directly on the thing. So the layout of a node is always defined, and so is the area. So these are not considered entities in this system. But anyway, the point I'm trying to make is that I built a system around this idea of having typed storage for things that I want to separate from components, just to not have two fat structures. I could put everything in the same structure, but honestly, when I printed it, it just bothered me that I'm printing things that are not defined in 99.999% of the cases. So I started to separate them, and then that's where I ended up. And I have been showing this code for a while now, and this is not relevant directly to the entity storage and the engine thing that I have running around. This is basically the implementation of the layout engine I already implemented in Rust before. I have basically re-implemented the entire thing in J, and I'm going to show you where I am at with it. So this is a little test case that I have, and this is something that I can just move around and inspect certain parts of the thing. This line here and the line around, basically right there, is the canvas. So I can move around the entire canvas, so I can inspect corners of it, and certain areas of it if I go outside. And I have another binding to my, WASD to change the scale of the root node, which is the largest rectangle here. And as you can see, if you know, this is something called a Holy Grail layout, where you have a top bar with some elements, a scaling middle bar, and a footer. And as I'm scaling it, basically the center part is what's losing most of the size. The height of the footer and the position of the footer is always in the same place. Same for the header. Some parts of the header are now outside of the boundaries of the original one, but that is because these have a minimum size, so they just overflow, which is normal. If I were to make it bigger, however, the brown parts actually grow to match or to distribute the available space around the center parts, which are fixed. That's basically a row and a column layout, along with what I call tensors. These are the elements that grow as allowed, and these work well in both row and column. So the center box is actually partially like that. And the other thing that you might have noticed as I have moved around everything, that this particular rectangle always stayed in the same place, even if I moved around the external one. And that's not because this is entirely separate. This square is actually a child of the middle section. So if I were to narrow it down, it actually goes outside. This is because this debug drawing that I have going on is drawing the tree of nodes, depth first instead of breadth first. So goes down to the children, draws them, and then draws the next child of the element. So first row, second row, children of the second row, and then the third row. So it just obscures the other one. Normally this should be above the other one in that case. But regardless, this is not like the rendering of this, is just debug things. Anyway, the point I'm trying to make here is that this rectangle is actually a child of the middle one, but even though I'm moving around the outer one, it stays in place. Now you could argue that it has an offset compared to the other one, but I'm going to prove you wrong. So now I have moved the large box elsewhere, you see, and that is because I have actually made both the root element, so the largest box, and this one pinned, which was a second part of the layout system I've built. So it supports the inlay things, so things that are in a rows or columns or whatever else layout algorithm I will add later. And another layer for positioning specifically elements relative to each other, which I call the pinned elements. So this one, this smaller rectangle, is actually pinned on its top left corner to the top left corner of this magenta thing, which is the viewport of the other one. Actually, it's a silly example of a viewport because it's narrowing the canvas to something which is not something you would normally use a viewport clipping thing for, but it serves the purpose. In any case, I made those things pinned. So this one is pinned to the magenta thing, and the large root node is actually pinned to the canvas. So when I'm moving it around, I can move it around like so. Now I'm pinning the top left corner to the bottom right of that thing. And I can pin that to the middle of it. I can pin it to the bottom left, and so on and so forth. So if I just put this back in the center, so now the top left corner is pinned to the center of the canvas, and I can change the which part of the which part of the root node I'm pinning to the canvas, and I just change it to the center of the thing. I can just go around and pins different parts of it. And the same goes for this little box. I can change which part I want to pin to the viewport, and I can change which part of the viewport I want to pin this to. And of course, I also have the ability to move the offset of that thing, which I believe is on control. Yeah, so I can change the offset compared to the pin. So if I reset everything and then reset the pin, so that's I'm pinning the center of the rectangle to the corner of the viewport there, or the magenta rectangle, and I can adjust the offset. And this might not make much sense right now, but believe me, those kind of adjustments are necessary basically to make good animated UI elements. So moving the offset a bit. So basically, if I pin something, let me just do it properly. So I'm going to pin the top left corner to the top left corner. So basically, if I have a portrait of some user or whatever on the top right, top left corner, I can then do a little animation that just moves it around a bit when you hover. So hover it, then go back. And to do this, I don't need to do expensive. Well, I need to do the calculation, so it's not like you can get away doing the calculations. But the adjustment is really simple because I'm adjusting only the position of the thing and not the entire layout. For the moment, that doesn't really matter because the calculations are done every frame. I don't have a good change detection system thing in place. It probably doesn't even make sense, in all honesty. I think UI will not grow to the point where it will be necessary, but it can be added if necessary. So it's not like I didn't think of that. The original implementation was actually based on change detection. So we only updated, or I only updated the parts of the UI that actually changed. I had to find the element that is like the boundary of that thing, and pinned areas are typically boundaries because they the external part of it or anything, any ancestor of a pinned element does not affect the layout of the pinned element. So anyway, those could be updated cheaply, because if you don't change the actual size of it, for instance, you don't need to recalculate anything inside. And where was I going with this? So looking at the code to change it. So first of all, the code to set it up is super straightforward. It's not great in the sense that because of how the type system is and how this language works, it's a bit verbose. It's a bit more verbose than I like it. But most of this will come from asset files or something, or I just have to type it out once basically, and I don't care afterwards. So I'm not really bothered by that. I even made this little a tree creation thing that just creates trees of entities, and it's all right. And the point about changing that offset is, let's see, I have a thing. It's like this one. So basically, when I want to change the offset of the pin, I just have to find, so I find the node that is currently being manipulated. You might have seen that I've moved either the big one or the small one. This is because I have a combination or a key press that I can use to change which pinned element I'm navigating or manipulating. So this one is just a handle for that, which gives me the node, and that should have a pin. If it has a pin, we just change the offset, and it's super simple. The 4 lines is because I have 4 directions. That's it. So this is the reason for the existence of pinned elements, because uh, they should be easy to manipulate in cases where you need pinned elements, and that's it. And the rest is also basically just simple. So one of them is to move the canvas, which just defines where the canvas rectangle is. And the other one is to set the scale of the root area. This is 4 lines only because I have 2 types of areas, basically. One of the inlay and one of the pinned ones. For the test case, I shouldn't even have this, because I always have it like this. But again, I tend to just change it to try things. But again, it's super simple because I only have to set the width, the percent, basically, and the height percent to change the entire layout. So when you see me squeezing that to the left, that's just me pressing one button, and it's just setting the percent of the bounds the area is taking, because basically scale 1 is the 100%. I can even make it bigger, by the way. And if I'm scaling down, it's less percent of the canvas, basically. Same for the other one. Everything else is calculated based on the layout that you have seen above me scrolling through. And that's great. Basically, I'm almost done with the layout calculations of the UI. I still need to account for the window scaling, which is something that different screens have a different scale to account for the high DPI monitors. I need to just update the pixel values with that scale. There's just many of them, so I kept it for the last part. All of these. When I do the calculations, these ones need to account for the scale. The percentages don't, but the pixel values do. So that's the last step I have to do, and then I have basically done the layout engine that I already had, but in the new language. And this is going to be the basis of implementing FireOpal, actually, because it allows me to actually create the layout that it had, and also probably the gameplay area. And the point is that this is just layout. It just calculates boxes and tells me where they are compared to the canvas. And the next step after I do the scaling thing is to implement the rendering, at least some rendering. I might not do the complete rendering thing that I planned for this, at least not now. But I have to get to a point where I can put images on the screen. And once that's done, it's time to implement the actual game. easy to say, but that involves me setting up Vulkan for the fourth or fifth time in the past 2 or 3 months. So that's going to be fun and time consuming. But at least it's going to look good, hopefully, once I'm done, and the debug boxes will be actually drawn with that. Because currently this is drawn by SDL, just render rectangle and lines, basically. And I want to replace that with actual going through shaders and everything. It might not be necessary. I could probably get away with just using SDL as my main renderer, but I want to apply shaders to certain parts because FireOpal did have some fancy shaders for the this lightning scrolling lightning effect on ties, and I want to implement that as well because that's what makes it a worthy project. I mean, anyway, I will get back to working on this, finish up the layout calcs, and start working on rendering. In the meantime, you have fun. Ciao, ciao.